All right. Today is what? 30th May 2023. All right. Today we are continuing with the course Ability 152, the topic Suppositories and Pastries. Now today we go into the factors affecting what? Drug absorption from rectal suppositories. So some factors that affect the drug absorption. Remember we talked about it's not just to, we said that it's not just to formulate or compound a suppository as case may be, and patient using the suppository. The suppository, go back to the hostel and sleep well. Go back there. Go and sleep. Leave that. I said hostel. Now, suppository, I said, now, this, as I said before now, it's not just about formulating patients in fact using the suppository. Will the active ingredients in the suppository be released? That's the point. So there are factors that will determine or affect the release and absorption of these words active ingredient from the word suppository. Some factors are drug related. Some may be the drug itself that is the problem. It may be those that affect the drug. Am I getting? Some may be the physiology of the patient. Am I getting? The physiology of the what? Patient in the rectal, specifically rectal what? Area. So some may also be the properties of the excipients, including the base, excipients or adjuvants, and even the base. Am I communicating? So there are three groups. Are we there? Some are physical properties of the drug, that is active ingredient. Some may be from the what? The excipient and the base. Some may be from the what? Physiological makeup of the what? The patient. Are we together? Now let's start with the physiological what? The physiological what? Factor. And what is she writing? What is this? Physics in Ability 152 class. Continue. Now let's look at physiology of human rectum. Just a brief physiology. Human rectum is approximately 15 to, this should be 15 to 25 or so cm. The structure of this thing covered it. Can you see it? When what? Empty. Am I communicating? 15 to 25. Are we together? Are we together? Yes. Good. When empty of fecal, you know what is fecal material? You know what is fecal material? No. Physics now. Physics. Is there any? Also affect what? I thought I was recording everything I was saying. Child. I wasn't recording. Child. I thought I was recording. Now when I 3 minutes can kind of since I'm gonna press the since for the past 1 hour. Child, yeah, with him. All right, let's continue. This recording helps not just me alone, my students too. Those that have data can work. Those that have data, you record it on your. Have you been recording? So know when I'm recording, what you're doing. So you've been recording. You see, okay. Now let's continue. Is what? That's why I'm crying now. 3 minutes kind of is that. I thought you without knowing. Demonstrating. Alright, let's continue, please. Let's continue. Okay, I got to go now. Life goes on, my brother. Such is life. Now let's look at the what other the properties of. Please tell me when it's 10:30, please. Physical characteristics of the word base. Hope you're writing your attendance. Hope it's passed. Hope it passes. Ask. Excipient. You can call it excipient or what? Adjuvant. It's okay. Not really. Prodrugs means that they need further, if they enter the system, they need further activation before they start exerting their effect. A prodrug, when it enters the system, cannot go and start acting immediately. A prodrug needs further activation before it can start exerting its pharmacological effect. Is it clear? Now let's continue. So nature of the base. So from what I said before in the partitioning, you can easily describe how the nature of the base affects absorption. True or false? You can describe it. But let's just look at it. So from what we discussed before now, if the base, let's assume, even though what determines the base is the drug, hope you know, even though what determines the base to use is the what? Drug, true or false? But let's assume you need to formulate this drug, and the patient needs this drug. And the base you have at that point in time, maybe you want to extemporaneously prepare suppository. And we have arrays of drugs, different drugs that can have the same effect in the system, right? But the base you have, let's say the base you have is fatty base, for example now, is the base you have. And you know that fatty base is limited to mainly what? Liquid hydrophilic drug, true or false? Now, and you have different drugs that can exert the same effect. If some of them may be lipid hydrophilic, some of them may be what? Lipophilic. But the base you have is you want hydrophilic base. What you have is what? Fatty base. Have you not seen that that base you have now will determine the type of what? Will not determine the drug you can formulate, since all of them can exert the same effect. True or false? You go and start looking for the what? Hydrophilic drug. True or false? Because you cannot go and start using what? Lipophilic drug. It will now determine the one to formulate. True or false? Unless now the only drug you have that can exert the effect you want to, the therapeutic effect you're looking for, is only lipophilic drug. You'll be forced to go and look for what? Hydrophilic what? Base. Because the lipophilic base will not give you what you're looking for. True or false? So that is another way now that the nature of the base can determine. True or false? Now, apart from that, there are some base that can cause irritation. If the base causes irritation, maybe it may be pharmacogenetic issue, or it may be just natural irritation. Maybe it may be peculiar to the patient or what have you. But the point is that any irritation caused by the base in the rectum, it will initiate rectal movements. And once the rectal movement is initiated, there will be no what? Absorption. Little or no what? Absorption. Remember our first statement that in resting stage, the normal rectum is what? Non-motor, right? Now, if a base is capable of irritating the mucosa of the rectum, it can initiate what? Rectal movement, and that will do what? Affect what? Absorption. Is it clear? And that will do what? Huh? A drug that is an example of lipophilic drug. Okay, good question. I like that question, but that will start taking us to something else. So. Something else too, which I don't want to go into. Use your phone now. Tell us. Use your phone now. See, there's something I want to tell you. Hello. There's something I want to tell you. The question you ask is okay, but there are sometimes when a lecturer is in class, there's some questions you can easily do what? Check up on your own immediately. Am I completing? To avoid distracting. And if you ask questions, you're not able to cover anything. Okay? Okay? That's why sometimes if I talk and I start going to pharmacology, I'll draw myself back because I'm doing what? I'm deviating. Okay? But just check it up. It's okay. Can't careful. Good. What else? Let's continue. Please, let's not waste our time. She can tell us if she finds one. Now, let's go. I think we are. Now, yes. And I'm saying now, I've been saying it here since now. That suppository is capable of what? Melting, right? Dissolving. Yes. Or softening. Now let me ask you a question. Let me ask you a question. Which of the suppositories do you think we talk about? Do you talk about when you say melting and when you say dissolving? I say which type of base? Base. When you say melting, what comes to your mind? What type of base comes to your mind? Fatty base, right? When you say dissolving, what comes to your mind? Hydrophilic base, right? We also have water dispersible base. Water dispersible what? Base. That one, it only disperses through of us. It doesn't dissolve, right? It can soften, okay, melting, softening, and what? Dissolving. I don't know if your question is clear now. Let's continue. Now, if you have adjuvant in the base, presence of other adjuvant in the base also affect what? Absorption. Now, do you know what you mean by rheological property of a substance? Do you understand by rheological property? Rheological. R-H-E-O-L-I-G-I-C-A-L. Rheological property. You go by your yeah? You go by your okay. Who has come in contact with that term, rheological? What does it mean? Rheological. What does it mean? You don't know. You talk about viscosity, right? Because viscosity is it part of it? You say me yes. You say me yes. Are you sure? What does it mean? Consistency, right? Whether it is the same thing I was talking about here, consistency I was talking about here. Whether is it viscous? How does it? Is it watery? How is it? Am I communicating? Now, the type of adjuvant you put in the base also affects its rheological what? Properties. Are we together? It will affect its rheological properties. Now, and this also will affect the what? Absorption, the release of the what? Active ingredient from the what? From the what? From the what? Drug. From the what? Suppository, right? Good. First of all, it will affect the rheological property of the what? Suppository. At the same time, of the suppository base, right? Then at the same time, it will affect the what? How this dissolution and release of the what? Of the what? Active what? Ingredient. Ika gun of ya? Now there is something I want to point out here. We are done with what? Factor affecting what? Good. From rectal suppository, right? Now there's a point I want to make here. Here, if you go down, you see the specifications for suppository. But let me discuss it, because when you go to property of an ideal suppository, you keep mentioning some points from these specifications. That's why I wanted to skip it, but it's important we talk about it. Because if you don't talk about it, by the time we enter the properties of an ideal suppository base, you start seeing terms like acid value, saponification value, and many of them. You will understand what they're talking about. That's why I want to talk about it. So let's look at specifications for what. So the specifications now, before you use before they say that a suppository base is good for the particular thing, these are some factors, some features they must see in the what? Base. These features may have a particular range before they can say, okay, this suppository is good for what? This particular what? Formulation. Is it clear? That's what you mean by what? Specification for what? Suppository what? Basis. So the first specification, there are 9 specifications here. There are 9 of them. The first you should look at is the what? The origin of this base and the what? Chemical composition. Come in. The origin of the suppository base and the chemical what? Composition. This time you must consider the origin. So where is this coming from? By origin we mean, is this suppository? Is it natural? Is it synthetic? Or is it semi-synthetic? You can call it semi-synthetic, or you call it what? Modified natural. Are we together? Semi-synthetic is dealing with what? Modified natural. So these are things. There are situations there are some things you want to formulate. You feel that you would need more of natural suppository base. Or it's okay, because of the natural suppository it has some issues in a particular temperature or whatever medium, we just use what? Synthetic base. Or let's use what? Semi-synthetic base. Or let's use what? Semi-synthetic base. Or let's use what? Semi-synthetic base. So these are things you consider. Now, a brief description of the composition of the base reveals, as you describe it, to reveal the origin, where it came from. Is it natural? Is it synthetic? Or is it modified natural products? Now, on the sharp here now, next thing you do for yourself is to look at the suppository basis now. By the time we discuss suppository basis, you start checking out on your own the one that is what? Natural. It's not everything that will be told here. Okay? It's not everything that will be what? So just like the question she asked. You can't expect me to sit down and start telling you everything. If I start telling you everything, I will not conclude this course. Are we together? There are some things that we mention, like we have mentioned hydrophilic. On your own, you say, okay, what are examples of hydrophilic? You look for it and make up your notes. Three of us. Even if I don't ask it in exam, you don't know where you see yourself what tomorrow. Now I am mentioning. Go back. Thank you. Now we are mentioning natural. I am very clear to you that some suppository bases are what? Natural. Based on their origin, right? Some are what? Synthetic. Some are semi what? On this map, on your own, you can look it up. Examples of natural suppository bases. However, you pick one or two. Keep it. You learn that one. Example of, okay, when do we use natural? These are things you can do on your own. When do we use natural? Is it which one can go with natural? I'm giving you clue on how to grow. So you don't become cram and pour. When you leave here, you become empty because there's nothing extra. Is that one they gave you in class? This is how to do what? Study. Okay? This is how to do what? Study. Now, apart from the source or the origin, you talk about the composition. What does it contain? Okay, can go. Physical or chemical compatibilities with other constituents may be predicted if the exact formal composition is known. Now, what the composition or the other composition of that suppository, whether it contains antioxidants, the base, right? Whether it contains preservative. There's some natural one that may contain all those things. All together. You check all those things now. The content will tell you, give you a clue whether any compatibility or incompatibility with any other ingredient. Any other ingredient used in the what? Suppository. Because if you don't know the composition, you may have issues. You may be interactive even though you're supposed to be inert. But sometimes it's that the natural one may contain some of these things that may interact with other words, other ingredients you are using in the word formulation. But an ideal suppository is supposed to be what? Inert. When we discuss properties of an ideal suppository, you understand that one. It's supposed to be what? Inert. That's what it should be. That's why you should specify all these things to be sure that they don't have any words, other component. Or even if they have, it's okay. All natural, you cannot do anything about it. But you will not use it for so words. So words. Formulation. Am I communicating? So this is what you check out in the what? Origin and chemical what? Composition. Then the second specification is what? Melting range. Melting range. Unlike other ingredient or whatever. So suppository they don't have a particular, you know what you mean by sharp melting point. Sharp. No points, not points. They don't have melting points. They don't have melting what? Points. They have melting what? Range. They start melting at this point, within this range, from here to here. They don't have a point. Melting point is at a point. It melts at 20 degrees Celsius. That at 50 degrees Celsius. That's a melting point. But range is. So what you have is what? Melting. So you have to take the melting range of the what? Suppository. So suppository bases don't have a sharp melting point. Their melting characteristics are expressed as what? Ranges. What does it indicate? It indicates a temperature at which the fat starts. You know, fat doesn't melt bomb. Have you ever seen fat melt bomb? Fat starts at a point and ends at a point. That's melting range. So fat doesn't have melting point. That's melting range. Now, so indicating the temperature at which the fat starts to melt and the temperature at which it completely melted. So how do you determine the melting range? You can use Willy melting point, capillary melting point, or incipient what? Melting point / softening point. All those blah blah blah. You can look them up and expand your knowledge. It is beyond the scope of what you are doing here. We just to mention them. Are we together? But you can expand if you. There's one secret I want to. Are you aware that provided you don't leave what you're supposed to learn and be reading one nonsense, and at the end you fail your exam. The point I'm making is, if you really want to understand what you are doing, each topic you read, first of all, understand what you are taught in class. Study what you are taught in class first. Try to do something extra in that topic. You see that you will grab it better. You will go beyond just cramming to write exam. Tomorrow you can have the confidence, for those that want to teach lecture, you have the confidence to talk about it. Lecturing these days lecturing doesn't necessarily mean coming here to be able to teach. If you are loaded, you can decide to be doing videos on your own, even where you are working. There's one pharmacy technician, in Lagos. If you go to his YouTube channel, the guy is dishing content steady. Pharmacy technician, if you see him talking about pharmacy, you think the guy is a pharmacist. Because he has the confidence now. He talk about it. What happened is that I saw he liked one of my lectures. I was like, who is this one technician? I went to his channel and I said, wow. What small boy like that? And he's doing well. If he's not loaded, can he do such thing? You can't even use the confidence will not be there. But the one you are taught here, how do you expand it? That's the point. You can contact the pharmacist. He keeps saying it, but at his level, he's doing well. So now, he's not teaching. He's working in one pharmacy. When there's no patient, he just use his phone and do lectures. And he's doing well. His YouTube channel is growing with speed. Now, let's continue. Now, so you can determine by what? Willy what? Melting point. Capillary what? Melting point. Or incipient or thaw point / softening. Incipient. You can look up all those things. Or thaw. / what? Softening what? Point. Let's move, please. So we don't waste time. That is the melting what? So you have to determine the melting. Do you know what? Someone tell me why you should know the melting rate of base that you do that thing. Can someone tell me why you should determine the melting rate of the suppository base they're using? Good, clap for him. Good. If the melting range is around 40 to 45 degrees Celsius, will it work? You made it the way it's two of us. So these are have you seen why I said specification to specify the base you are using to be sure that it will help you to achieve your what purpose. That's why we are looking at this what specification. Now the next one is what? Solid fat index. You call it SF what? I. Solid fat index. Solid fat index. Simply known. You just talk about the solid in the what? The fat. I'm not forgetting the amount of solid in the what? Fat. The solid fat in the entire fat. True of us. Now let's go. That's what this thing is trying to let us know. So with this now, one can determine the solidification. If you know the solid content of the fat, you can determine the solidification and melting ranges of fatty bases, as well as the molding character, surface feel, and hardness of the what? Bases. Now, the content of the solid fat there, you can easily determine the hardness of the what? True of us, how hard the base can be. True of us. You also determine how it feels, the surface feel. True of us. After formulation. True of us. You can also determine the molding character. You remember, you pour it in the mold, right? Allow you to do what? So, if the solid content is not much, it may not mold, it may not form more, the solid may not be that okay. True of us. It cannot mold and give you that solid you're looking for. Because on whatever, there is no other solid. You can't import solid from anywhere. if the fat, the base you are using, what is the solid content? If you cannot import solid from somewhere, if you solidify, can it give you the solid consistency you are looking for? Is it clear? If it has no enough solid fat, it cannot give you that. If after molding, it can't give you the solidification you are doing what you are looking for. That's why they take this what solid fat what index. Now, look at another point. A base with sharp drop in solid over a short temperature, even a short temperature span, the base will just drop in solid. Do you think it will give you the solid you are looking for? No. It will be brittle. It will do what? Be brittle. It will what? Brittle. Because only enough solid what? Content that will give you the solution you are looking for. Are we together? So that's the point that I want to make here. That a base with sharp drop in solids over a short temperature span proves brittle if molded too what? Quickly. Now, there's another point I want to make here. That the solid content at room temperature could determine suppository what? Hardness. I think I mentioned it here. Hello? The solid content at room temperature, normal room temperature, the solid content of a suppository. Hello? At normal room temperature, it will be the base. The solid contents of the suppository at that room temperature will tell you, we speak about the hardness of the what? Suppository when you use it to do what? Formulate a what? Suppository. To tell you how the hardness will be. Or toward the at room temperature will tell you how the hardness will be when you use it to do what? Formulate a what? Suppository. And if it's solid, good solid at room temperature, it's good for your what? Suppository. Because at normal room temperature, it will just melt. That means you can't even transport it. You give me the cold chain. Bring a fish na guy. So these are things you check. That's what solid fat index is trying to do. What? Let us what? Know. And another thing is long story. Now, another point is what? The solidification point. You also check the what? Solidification point. Remember, you check the content and the origin, right? You check the what? Melting range, right? Then you check the what? Solid fat index, right? You check the what? Solidification point. Now, what does solidification point do? It allows you to determine the time required to solidify the what? Base. It allows you to determine the time required to what? To solidify the base when it is chilled in a what? Remember, by the time we start the production of suppository, you will know that in the mold, you chill it a bit. It will be allowed to do what? Chill, right? Now, when it's chill in the mold now, this thing will help you to determine the time it will require to do what? Solidify. Yeah, what you mix is not in solid form. That's why you can pour it in the mold. If you pour it in the mold, solidification points of that base will help you to know how long it will take that thing you pour inside the mold to become solid. Is it clear? Solidification point will help you of the base you want to use, will help you to determine the time it will take for that thing you have melted, mixed, and poured in the mold to turn to what? Solid what? Suppository. That's what solidification point is trying to do what? Let us what? Know. They say that if the interval between the melting points, listen carefully. I want to make a very important point here now. Just listen carefully. That if the interval between the melting point and solidifying point is 10 degrees or more, time required for solidification may have to be shortened for a more efficient manufacturing procedure by refrigeration. Let's assume now, even though it has a range, right? It has a range, right? The particular, that end point, that particular end where that last temperature where it dissolves, it melts, right? Now, if you check the time, if you check the time the particular base solidifies, when it solidifies, and check the when it completely melts, right? And subtract the two of them. If the difference between the two of them is 10 degrees Celsius or more than 10 degrees Celsius, what it means is that you really need to do what? Work on it. And how do you work on it? You need to work on it by shortening shortening the what? The time for what? Solidification, for a more efficient what? Manufacturing procedure. And how do you do that? By what? How do you do that? By what? Refrigeration. By putting it in what? Fridge. Hello? A particular, that's why if they want to tell you to use a particular suppository base, you be advised to use to, after pouring it in the mold, refrigerate. Are we together? There's one they will tell you, after using the particular base, after pouring it in the mold, you must do what? Refrigerate. All that type of suppository base kind of what they have. That from the after accepting the suppository base, now they have determined that this suppository base, if you check the melting point and the solidification point and subtract them, is more than 10 degrees Celsius. What it means is that if a particular suppository base, the difference between its melting point and the solidifying point is more than 10 degrees Celsius or 10 degrees Celsius or more than, anytime you want to use such suppository, for what? Such base for what? Preparing suppository. After pouring it in the mold, you must do what? To do what? Shorten the what? Time of the what? Solidification. Am I communicating? So that's the reason why you check what? Solidification point of a base. Remember, this are the specification of the basis, not suppository itself. The basis, and they use for what? Suppository. That's why there are some you don't need to put in fridge. Once you just pour them in, you allow them to do what? Solidify on their own. There are some you will do to put it in what? So these things are what they have specified when they were manufacturing the what? Excipient, which is the base. Remember, I told you there are companies that focus on what? Excipient production to come off pharmaceutical what? Grade level for production. Now, as they are processing that excipient base, they check all these things. They will check the solidification point. Check the difference between the total melting point and the final melting point and the what? And the what? Solidification point. If the difference is 10 degrees Celsius or above, you will be advised to do what? Always refrigerate after what? Pouring it in the mold. But if it's less than 10 degrees Celsius, you don't need to do what? Refrigerate. Just pour them in the mold and allow them to do what? To solidify on their own. You don't need refrigeration. Am I communicating? Yes. Because if you don't put it, you keep it there. They may remain there. Only God knows when they will do what. Solidify. Am I communicating? That's the point you are making in this what? Solidification what? Point. Now let's continue. Please, 10 and let me know. No, I still have 3 minutes. 3 minutes is a very long time. Yeah. Hydroxy value. So you look at the what? Hydroxy what? You have a question? You don't need to do. You don't do. After using that suppository base for production of the suppository, you don't need to do what? Just pour it in the mold and do what? Allow them to do what? Is it clear? That's the point I'm making there. Then another thing, you take the hydroxy value. The hydroxy value of the what? So is it the hydroxy value of the suppository or suppository base? Good. Now, what is hydroxy value of a suppository base? Hydroxy value of a suppository base is the number of milligrams of potassium hydroxide that would neutralize the acetic acid used to acetylate 1 gram of fat. I said the hydroxy value of a suppository base is the number of milligrams of potassium hydroxide that would neutralize the acetic acid. Number of milligrams, yeah, of potassium or you can simply say the amount in milligram. True of us, the amount in milligram for easy understanding. The amount in milligram of potassium, but the amount must be in what? Milligram. Is it clear? That's why they say number of what? Milligram. Or the amount in milligram of potassium hydroxide that would acetylate the acetic acid. Sorry, that would neutralize, not acetylate, that would neutralize the acetic acid used to acetylate 1 gram of fat. You use where do you stop? Read it. Okay. Acetic acid used to acetylate 1 gram of what? Fat. This simply want to use this hydroxy value is just trying to let us know the amount of the graphia. Have you heard of? You are doing organic chemistry, right? Did you get up to fatty acids? Okay, no. But in your secondary school, those that did organic chemistry in school, you must have done about glyceride, triglyceride, all those things. Those that did organic chemistry, triglyceride, all those things there. So this one, you want to use to check the mono and diglyceride content of the what? Fatty base. Am I getting? You want to use this hydroxy value to determine the mono and the diglyceride content of the what? We use this hydroxy value to determine the what? Mono and diglyceride content of the fat. You know that fat is made up of what? Fat is made up of what? Basically. If you do hydrolysis of fat, what will you see? And what? Say. And what again? Hey. Can everybody do video? Time is go up here. All right, we'll stop here. So, okay, did you have a question? Ask. Ask. That's what? How it can be transparent too. There are hard capsules you can see the content inside. I've seen them. Hard capsule. There are also hard capsules that foreign agents. Those points they do have for. Don't use them as a standard point. Because these days they formulate a lot of things these days. Okay? Huh?